CubeSat NB Earth Station site measurements of potential background radio interference on the roof of Gillin Hall, University of New Brunswick, Fredericton, New Brunswick, Canada, May 13th, 2021. CubeSat Violet's radio information page is shown here, and a link is in the video description. Our group used Jan King's link budget spreadsheet template for CubeSat Violet. If Violet transmits plus 30 dBm from space on a 2.4054 GHz carrier, and there's a minus 160 dB path gain from space to Earth, followed by a plus 30 dB satellite dish antenna gain, then it equals approximately minus 100 dBm received signal at the antenna output. Our concern is if there are Wi-Fi interference signals arriving at a level of minus 70 dBm or higher at the side of the satellite dish. Even minus 80 dBm interference at the effectively from the side of the satellite dish may be a problem. So, checking Wi-Fi signals. This is Gillin roof. Over here is where we're doing the measurements. So we have power here on the wind-up coil. Okay, you can wave, Troy. Setup is over here. So voltage on the line is good. We checked with a voltmeter, 300-foot extension cord, lots of spare equipment. This is the setup, that 12-foot C-band dish, about it, and the antenna here, the cable, spectrum analyzer, Wi-Fi access points here. We would expect a long pass from Violet might start over on that horizon and go over here. Some passes might go this way. Using the old astronomer's trick, this is about 30 degrees off, 30 degrees off the horizon. That's not going to work. Measurement change. Wi-Fi hotspot on the phone, frequency 2.4 to 2.5 gig with a resolution bandwidth of 10 kilohertz. The E440A, this antenna just taped on with masking tape, and a phone with a Wi-Fi hotspot, so we can see the Wi-Fi hotspot. We're up here again on Gillin, looking around for Wi-Fi signals. Well, I can always edit Troy out of this, so even in.
Why do you do that?
Measurement change. 2.4 to 2.5 gigahertz, resolution bandwidth 10 kilohertz, averaging on 100. The antenna is pointing here at the phone, which has a hotspot on it that's over there on the edge. You can detect the presence of the phone by a small bump there on the display. Measurement change. Video on. It's 2.4 to 2.5 gig. Attenuation 10 dB, dynamic range. This is a resolution bandwidth of 1 kilohertz sweeping across. You can see the sweep slowly move across, and looking at the presence of signals on the band. Again, the full range on the abscissa is 2.4 to 2.5 gig. It's 100 megahertz. Violet's frequency allocation is way over on the left, only 2 megahertz. So again, 500 megahertz wide, and we're only in the left at 2 megahertz. Again, this setup is that 5 dB log periodic on a cable about 10 feet long. And there is that access point over there. And that phone on the ledge. And the sweep is done here. Well, we're going to do this sweep one more time, but with no phone. Measurement change. All right, 2.4 to 2.5 gigahertz sweep, 1 kilohertz resolution bandwidth. You can see, and again now, same access point, but there's no phone. We're pointing at Wi-Fi access points on the other side. The angle's about right. It's pointing down towards the access points. We'll compare this display to the previous one. This one has no, the only difference is we turned off the Wi-Fi access point on the phone. And you can see there's no Wi-Fi access point there, but there are other signals present. And again, it's over on the left of the display where we're looking for signals from Violet, around over on the left in a 2 megahertz bandwidth, and that's about 500. The sweep is almost done. So again, 10 dB attenuation, reference level 0 dBm, resolution bandwidth. Okay. With the phone hotspot on, we got this trace. With the phone hotspot off, we got this one. You can see the hotspot signals here. There's some time variations in the signals observed. Violet's frequencies are between 2.4044 to 2.4064 in the range indicated by red here. Measurement change. We set the frequencies to be for Violet 2.4044 to 2.4054. The resolution bandwidth is right now 100 hertz. Takes 36 seconds to sweep across the display. There is nothing. There is a 10 dB attenuation, 10 dB per scale, reference level 0 dBm. If I set the resolution bandwidth to 1 kilohertz, then the sweep time is 2 seconds across the display, and if I set the resolution bandwidth to auto and it flips to 18 kilohertz, then you can see low-level scans across the display. This again is for this setup. No signals detected. Measurement change. It's a resolution bandwidth of 18 kilohertz. This is on the display. There are blips down at the noise level. We get these same blips at the noise level. Same blips at the noise level, even though this antenna is being rotated 360 degrees around the horizon. We see the same, there just doesn't seem to be anything, even pointing up towards that Freddy zone, old Freddy zone access point.
I don't think that works.
Measurement change. All right, we have about an 18-inch diameter Wi-Fi dish. That hotspot is active. It's the frequency is 2.4 to 2.5, resolution bandwidth 900 kilohertz. And if you look on the display, you can see that big blip right in the middle on the 500 megahertz bandwidth. Next, we'll turn off this hotspot and compare. Only change. Turning off the hotspot. Is it off?
Stop it.
The only change. So we don't see the hotspot at all on here. So the antenna looks like it's working out. So we'll aim the antenna, change the bandwidth. Measurement change. So again, this is 2.4 to 2.5 gig. And we are Yeah, there's something over there on the left. This is from this pointed over at about here. Those look like, that looks like Wi-Fi. So I think what we'll, that's again 2.4 to 2.5 gig and a resolution bandwidth of 910 kilohertz. Going back 29 seconds and freezing it, this signal was observed. Violet's frequencies are 2.4044 to 2.4064, indicated by the red line. This indicates an interfering signal. This might be all right, or it might be close to the level of the signals from Violet. We might be able to mitigate this by changing Wi-Fi access point frequencies or using error control coding. Measurement change. We're going to do the 2.4 to 2.5 gig resolution bandwidth 18 kilohertz 360 degree sweep of that antenna beginning now for about a 30-second sweep, and I'm recording the display. It's all at noise level. Oh, these are Violet's frequencies. Sorry, it's 2.4044 to 2.4064. 360. Going back 2 seconds and freezing it. There was an antenna with a gain of 20 dB used during the test. Although this is an excessively approximate set of measurements and analysis, it is at least something. Measurement change. All right, so we're going to do again, frequency range 2.4044 to 2.4064. There's that 10 dB attenuation. The resolution bandwidth is now set to 1 kilohertz. So it takes about, takes 2.5 seconds to sweep across. So we're going to point this antenna over at the building in 4 places for 3 seconds, 3 seconds, 3 seconds, 3 seconds, and look at the display beginning now.
Running ready?
Yeah, ready, recording, ready.
You want to count it down, Brett? 1, 2, 3, 1, 2, 3?
Sure.
1, 2, 3.
1, 2, 3. 1, 2, 3. 1, 2, 3. Nothing. We concluded that the CubeSat NB ground station site was free from any strong sources of interference. We thank Dr. Walter Rawle for his suggestion to do the measurements. If you have any suggestions or comments for us, please let us know. CubeSat NB is a first-of-its-kind partnership involving the New Brunswick Community College, the Université de Moncton, and the University of New Brunswick. We acknowledge our primary funding providers, the New Brunswick Innovation Foundation and the Canadian Space Agency. Thank you.